So till now we have seen so many things. We have seen build heap, we have seen maxipify, we have seen how to delete a maximum element, we have seen how to increase a key of something, okay? And the core of the heap is max heapification, okay? If you are using the max tree, then max heapification. If you are using a min tree, then min heapification, okay? So now we will be seeing heap sort, and in this heap sort we will be seeing that, and in this heap sort there is nothing. We will be given an array and you have to sort that array. Okay, we will be given an array, you have to sort that array in ascending order. Fine. So this is heap sort, or in descending order. Fine. We will be given an array and you have to sort that array in ascending order. This is heap sort. Now how heap sort works is, for example, this is my tree and this is my array given to me, and this is from this array I have drawn this tree. Correct? Now what is happening here? The first step is build heap. The first step is build heap. Now I am explaining the algorithm. The first step is nothing but build heap. Correct. Where the build heap starts from, now you know everything. Now tell me where the build heap will start from. Just think where the build heap will start from. So where it will start, it will always start from the first non-leaf element, that is from here. So here the build heapification process will begin, the build heap process will begin, and it will call max heapify and it will be heapified. Okay, fine. So like this, the whole tree will be heapified first. So the first step is build max heap. Let's see. So first, the heapification process begins on 15, so 20 and 15 will be swapped, as we know. You know now how this is done. So this is heapified. Now next, build heap will be point to 30, and it will check its left child and right child. Yes, right child is greater, so it will swap it. So it will swap it. So 50 and 30 are swapped. So the left child is heapified, the right child is heapified, and the root is greater than everything else. So finally, we will get this tree. So this is the build heap tree. Okay, the heap tree, that every node is following the max heap property in this tree. So the first step is complete. Now the next step is a for loop, and in this for loop what is happening, from the length a of length, that is the maximum size of the array that I have right now, that is 1 2 3 4 5 6 and 7, from 7 to 2. Why to 2? We will see why till 2 only, why not till 1. Okay, from 7 to 2, what we have to do, we have to swap the first element with the I element. Swap the first element with the I element. So I is currently pointing to 10. I is currently pointing to 10. Yes, correct. And the first element is 200. What you have to do is you have to swap 210. You have to swap 210. So the first step is swapping 210. Yes, so 200 came at the end of the array. 200 came at the end of the array. So now you can see that the maximum element came at the end of the array. We want this. We want to sort the array in ascending order. So the maximum element should be at the end of the array, and it is at the end of the array. The next is decrease the heap size. Decrease the heap size. So let's decrease it. We have decreased the heap size. Heap is this much only. Okay. So this is not in our heap. Now this is not in our heap. Correct. So after that, what you have to do is, since now we do not follow max heap property at root, we are not following a max heap property at root, you have to call the max heapify at root. You have to call the max heapify at root. Fine. So in this heap sort, max heapification will always be called from the root. The max heapification will always be called from the root. As you can see, we are passing our array and we are passing out the first index. So the max heapification will always be called on the root. Fine. So 200 is at its correct position, and now we are calling the max heapify function. So 10 will be, you know what will happen in the max heapification now. Correct. So what will happen? It will check its left child and it will check its right child. Then what will happen? The largest element will start pointing to 50, and we will swap 50 and 10. We will simply swap 50 and 10. Correct. So now it is swapping 50 and 10. It is done. We swap 50 and 10. So again the max heapification will be called. Now that is recursion, correct? In the max heapification. So left child and right child. So 30 is greater. So it will swap 30 and 10. So it will simply swap 30 and 10. And after swapping, we get this tree. Okay. And then again, this is now heapified completely, and finally we get this tree. So after the first for loop is over and the build heap is over and the first for loop iteration is over, this is the answer that we are getting. In the first for loop, we are getting our maximum element at its correct position. Now I think you know how this process will work. In the second for loop, since now the largest element is at the root now, see, the largest element came at the root. So after every process, after every iteration, the largest element will end up at the root, and what we will do is we will swap the largest element with the last element of our heap. We will swap the largest element with the last element of our heap, and we will call again the max heapification process. So this thing will be repeated again and again. Let's see now. 50 is swapped with 15, root will swap with the last element, so 50 is at its correct position now. Yes. After that, heap size will be decreased by 1. So yes, it is decreased by 1. After that, on the root, max heapification will be called and it will be heapified. So 30 will be swapped with 15 because 30 is greater than 15 and 30 is greater than 20. So 30 will be swapped with 15. So yes, it is swapped. Now, is it heapified? Yes, I think the tree is now heapified because 15 is greater than 10 and 5. 30 is greater than 15 and 20. Yes. So this is the tree after the second iteration. After the second iteration, the tree is this. Correct. So 50 and 20 are at its correct position. Now just think what will happen. What will be the next step? We are again back here because it is iteration. So again it will start for the root 30. So what is the next first step? Swap the root and the last element. The last element is nothing but 10, which is pointing by the I, and this is nothing but the first element. So it will swap. 30 and 10 are swapped. See, yes, 30 and 10 are swapped. Then the next step is decrease the heap size. So it will decrease the heap size. Now you know what is the process. These are only the 3 steps that we are repeating again and again. Now heapify, because the root is not following the max heap property, so just heapify it. So here we heapified it, and this is the result that we got after the third iteration. Okay, so after third iteration, I got my 3 largest element at the end of the array. Fine. Now repeat the same process again. Now 20 and 5 will be swapped. 20 and 5, because 5 is the last element here. We have decreased the heap size, correct? So 5 is the last element here and 20 is my first element. Just swap it. So we swapped it, decrease the heap size, that is the second step. Swap, decrease it. After that, call max heapify on 5, because it is not following the max heap property, we are calling the max heapify function. So we are calling it. So 15 will come here. So this is the tree that we get after the fourth iteration, correct? Now you know what will happen. 15 is the root and 10 is the last index, the last element. So they will be swapped. So they are swapped here. Now after that, the heap size will be decreased. The heap size will be simply decreased. And on 10, the max heapification will be called. It will see it as a left child. It does not have a right child. Is it greater than the left child? Yes. So swap it. So they will swap it. And after that, after the fifth iteration, I get this tree. Okay. Now my original size was 7 and 5 iterations are done. So my size becomes 2. So we have to come down to only 2. We have to come down to only 2. Now you can see that after I came down to 2, my array is actually now sorted. My array is actually now sorted. Why? I have 5, 10 at this correct position, 15, 20, 30, 50. These 5 are my iterations. So using those iterations, I have my correct positions and correct element at my correct position, and 5 and 10 are automatically at their correct position at the end. So we have to come down to 2 only, because when the 2 elements are left, they will be at their correct positions after heap sort. So this was heap sort. I think it was pretty easy to understand heap sort. First, whatever array we have given, we will convert that array into a build heap. We will convert that array into a build heap, and we have seen how build heap process will work. After that, there are 3 steps which are going to be executed. How many times? The length to 2. The length to 2. These many times, these 3 steps will be executed. The first step will be simply to swap the root and the last element. The second step is to decrease the size, and the third step is to call the max heapify on the root. Okay, so these are only the 3 steps which are going to be repeated again and again, and on every iteration we will get one element at its correct position from the end. Fine. I think it was pretty clear. It was pretty easy to understand. If you want, I can explain you the same process again, or you can skip this part of the video when I'm explaining the same process again. So first, this was my tree. The build heap function will be called, and it will be heapified. It will be heapified. So this was heapification. So after heapification, as you can see from here 30, and here is 30, correct? Here was 30 and here was 15. So after heapification, this is changed to 50 and 20, correct? After this, what we will do these 3 steps. 200 will be swapped with 10, and after that, heap size will be decreased by 1, and the max heapification process will be called. After that, 50 will be swapped by 15, and heap size will be decreased by 1. See, the heap size is decreased by 1, and the heapification process will be called on 15. After that, again 30 will be swapped with 10, and the heap size will be decreased by 1, and the heapification process is called on 10. After heapification is done, 20 will be swapped with 5. Heap size will be decreased by 1, and the heapification process will be called on 5, and the same process will continue. So this was actually pretty simple. Okay, the heap sort is not hard. Heap sort is very, very easy if you know what build heap is and if you know what max heapify is. Okay, now I think you can implement this. This is just a function. And you have to just write these steps. We have already implemented build heap. We have already implemented max heapify. Now what you need me for? Okay, so just write this function down in our code. Just write the function down, and when you write the function down, just run it, and I think you can simply do it. It's very easy now. It's not hard. It's very, very, very easy now. Okay, so I will write it. Just pause the video and just write on your own, and then just cross verify with my code and just try and run it with different inputs. You will get different outputs and you will see that your code is correct. Okay, this is for max heap. You can do the same thing for min heap as well. You have to do it, you should do it. Okay, now I'm going to write the code in our program that we have been using from the past 2 or 3 videos. So here what we are going to do is we are going to simply create a heap sort function, heap sort, and in this heap sort function our heap which we are going to pass is actually present as a global variable here, so we do not have to pass it in this. We can directly use it. So first step is called a build heap. Next step is int length equals to size. Okay, because we are going to decrease the length one by one, we need to store the size somewhere. Fine, because we are going to decrease it one by one. So int I equals to size, so the original value should be stored. Then the next step is I greater than equal to 2, from size to 2, and I minus minus. Now simply there are 3 steps. What was the first step? First step was swap. So swap the first one with the pointing one I, that is the last one. Then decrease the size by 1, then think what was the next step. Now you know what was the next step. It is always the next steps: maxify, heap, and I. Correct? Done, complete. This was the code, and at the end just make the size whole again. Because you need to print the array, and the array is represented using the size, so you need the size again. Fine. So this is the same process what we have done so many times. Now what you can do is, after this step, you can just comment this whole thing down, because this will just come in between this whole process. And what you can do, this process is used for insertion, so we will use this for insertion. After that you can just simply call max heap dot heap sort. Correct? So the heap sort will now call the build heap function that we have used here, and it will call the maxify function also in itself only. So therefore we are commenting these whole things down. Correct? Because heap sort will do the max heap and heapification by its own. Fine. And after sorting, so you can just print that after sorting, just print it. Okay, print it. So max heap dot print heap. Okay, and you can also write here before sorting. So s out before sorting, and you can simply write max heap dot print heap. Fine. After insertion, what we have, and after, okay, so before running, I think I have made some mistake here. So it is not heap I, but it is heap 1. Let's check. Yes, it is heap and 1, not heap and I. Okay, I think you have, when I was writing, some of you may have got this error. Okay, you have got that I have made a mistake here. Okay, so now I am correcting it, and now let's run the code. Fine. So it should run. Fine. So now let's run the code, and after running, just input the values. That is 200. After 200 we have 30, then we have 15 and 5, 50, then 20 and 10. So now you see, before sorting, this was the original array which I inputted, and after sorting my answer is 5, 10, 15, 20, 30, 50 and 200. So if you want, I can show you how this process is working. So after insertion, the max heap sort will be called, and just copy this one, and we will use the debugger to show the flow of the program. Okay, I will just show you the flow of the program, where the calling functions are going, what is happening. Fine. So let's see. Now variables, the heap sort will go. So first build heap will be called. So now whole build heap process will occur. The maxification will occur, the whole build heap process, everything that we have seen till now. Okay, so this heap is now build heapifying. Okay, it is now heapifying, max heapifying. The heap that we have inserted is now heapifying. Fine, I have shown you this. After heapification, so the heapification is over. Now we will swap the first and the last element. So we are swapping the first and the last element. Fine. So as you can see now, 10 became the first and 200 becomes the last. Then we have to decrease the size, so we are decreasing the size to 6. Then we are calling the max heapification on 1 to 6. From 1 to 6 we are calling max heapification. So now 10 will change and 50 will come to 10. This will swap, and the max heapification process is running, and after the max heapification process is over, we will get our answer. This is really simple now, because we know how the max heapification process runs. Fine. So this is the whole process that is running here. Say 15 came here, 10 came here, correct? But now I think 10 will be swapped with 30 also. right? 10 will be swapped with 30 also. So that process is now running. 10 is swapping with 30, as you can see now. 10 and 30 are swapped. Okay, so now the heapification is over. So I think now it will return me a true. So it returns me a true, and we are back in our heap sort. Okay, so the first process was over. That is the first, what you can say, iteration is over. So at the first iteration I got 200 as my on my correct position, and I got the second largest element at the root. Okay, now this will be swapped with 15. This will be swapped with 15, as you can see here. 1 second. Yes, see, 15 and 50 are swapped now. Now on 15 the build heapification process will be called again. Okay, size will be decreased by 1, and from 1 to 5 the heapification process will be now called again. Fine. So this was the whole process of heap sort. I think you understood what was heap sort, and in the end we will get simply our output. At the end we will simply get our output after sorting. So this will just print my elements 5, 10, 15, 20, 30, 50, 200. Fine. So this is printing my elements. So this was heap sort, and this was the Java implementation of my heap class. Okay, so heap, we have what we have here. We have the max size, we have a size, we have an insert method, we have a build heap method, we have to check a function for isLeaf, we have to check a function for max heapify. Also there is max heapification function. Also we have a print heap function, we have a swap function, and we have a function for extract max, for increase key, I think, yes, for increase key, and for heap sort also. Fine. So if you have this function, max heap function, this that we have created, you can call this any number of times, this class any number of times, and use it to create different types of heaps. Okay, all those heaps will be max heap, and you have to create your own class for min heap. Now what you have to do is just understand the concept and do this for min heap also. Okay, do the same code for min heap. Instead of max heap, use for min heap. Okay, wherever this is greater, there should be a less than. Now you know what min heaps are. Just think and use it. Just think and code the same thing for min heap also. Fine. So this was simply our heap sort completely. Okay, from the beginning to end we implemented in Java our heap class. Fine. Thank you.